Here's a question that was asked over email. It's from section 11.5 and it's number 5. And they ask you to evaluate the combination, so this combination right here. And this is the notation that they use. It looks like just a parenthesis with a 3 on the top and the 2 on the bottom. Combinations are defined to be if you have NR, so the n is the number in the top and r in the bottom. That's a combination of n things taken r at a time. It's defined to be n factorial over r factorial times n minus r factorial. Okay, so a combination it's one of the things that we use in probability and counting techniques and whatnot. And so what we're going to do with this combination right here, 3, 2, is we're going to basically plug it in. Everywhere there's an n, we're going to plug in 3, and everywhere there's an r, we're going to plug in 2. Okay, so this 3, 2 is going to become 3 factorial over 2 factorial times 3 minus 2 factorial. And what we're trying to find is 3 things chosen 2 at a time. The other notation for this is a combination of 3, 2. So there's different ways to represent it, but factorials, when we represent the factorials here, this is 3 factorial over 2 factorial. 3 minus 2 is 1 factorial. We know that 1 factorial is just 1, so I'm not even going to worry about it. And then on the top, I can write 3 factorial as 3 times 2 factorial. I can extend it down to the other 2 factorial. And so these 2 factorials will cancel, and I would be left with 3. Okay? All right. Maybe I should just give you a little background on factorials. I guess that's not really what the question is about, but just to let you know what factorials are. Basically, if you have n factorial, it's equivalent to n times n minus 1 times n minus 2, all the way down until you have times 3 times 2 times 1. So this exclamation mark here is a representative of what we call a factorial, and it's just defined to be taking every number times itself beneath it. So, you know, for instance, if I was to take a 6 factorial, that would be 6 times 5, 4, 3, 2, and 1. Okay, so you'd multiply all those numbers together, and whatever you get there would be the equivalent of 6 factorial. So that's what I was doing up here, was I was actually just extending a portion of the factorial. I know that 3 factorial is 3 times 2 times 1, but 2 times 1 is the same thing as 2 factorial. So if I stop right there at 2 factorial, then I can cancel this 2 factorial with that 2 factorial and not have to write them out any further. It's not a big deal with 2 factorial because it's pretty small, but if this was like a, 13 factorial, and you wouldn't really want to write that out, so...